Hi everyone, I'm Cheryl. In this problem, we're asked to set up a double integral that will describe the volume of a region bounded by the plane z equals 4 minus 2x and the paraboloid z equals 4 minus x squared minus y squared. Now, to kind of envision what's happening here, we have a paraboloid and we're going to be slicing it with the plane. The region that we're looking for the volume of is that curved part that will be on top of the paraboloid, but will have the flat bottom of the plane passing through. All right, in order to do this, the first thing we're going to need to know is the region over which we're going to be integrating, which means I need to find the intersection of my paraboloid and my plane. So to do that, since both of those equations are set equal to z, I can set them equal to each other. So I'll have 4 minus 2x is equal to 4 minus x squared minus y squared. Okay, so what I'm going to do is move everything to one side of the equation, and I have x squared plus y squared minus 2x equals 0. Now you may recognize that this is a circle. We can do a little bit of algebra to put it in a more easily recognizable form. So let's take a look. We'll go x squared minus 2x plus y squared equals 0. X squared minus 2x, and I'm going to add 1 to both sides. And now I can factor that first group of 3 terms into x minus 1 quantity squared plus y squared equals 1. This is the standard form of a circle, so it's more easy to see. So let's go ahead and take a look at the picture. This will be a circle whose center is at 1, 0. So that's right here. And I know that the radius is 1. So I'll move up and down 1 unit and left and right 1 unit to help me draw in my circle. All right, so remember what I want. I want the volume. And to calculate the volume, I'm going to take the volume under the paraboloid and then I'm going to subtract the volume under the plane. Okay, so to get the volume under the paraboloid, what I'll do is I need a double integral, and I'll be using the equation for the paraboloid. So that will be 4 minus x squared minus y squared. Now I need to determine the order of integration and also the limits of integration. So I'm going to go back over here to my picture, and I'm going to draw in a representative element. And I could do this either vertically or horizontally, but I chose to do it vertically. And I'm going to look at little pieces that make up that representative element. Okay. All right, if I do it in this way, I've chosen to do dy dx. So I'll go ahead and mark that on my integral, dy dx. So now I need the appropriate limits of integration. So when I change y, I'll be going from this curve up to that one. All right, so now remember, this is the top half of my circle. So I can write this as y equals the square root of 1 minus the quantity x minus 1 squared. The bottom half of the circle is y equals minus the square root of 1 minus the quantity x minus 1 squared. So my limits of integration will be exactly those functions. So I'll go from negative square root 1 minus the quantity x minus 1 squared to a positive 1 minus the quantity x minus 1 squared. All right, now for my limits of integration associated with the x. Once I have that rectangle built, I'll be going from 0 out to 2. So those limits of integration are just 0 and 2. Okay, so that should give me the volume under the paraboloid about that region. So now I have to subtract the volume under the plane. And this time, the limits of integration are going to be exactly the same thing. However, since I'm looking for the volume under the plane, I need to be integrating 4 minus 2x. And again, my order of integration was dy dx. I'm going to insert some parentheses just to be clear here, but that's my result. I hope that was helpful. Thanks.